In this video, we're going to be finding the second derivative. We've previously done simple derivatives, we've done log, we've done ln, all that good stuff, but now we're actually looking at second derivatives. So this is pretty important when we want to derive things multiple times. We have this equation that we're going to look at. So the first derivation we did in green, and the second derivation we did in red. So we're going to look at the first one. The first one, it's pretty simple. We do have this negative in our numerator right here as our exponent. Now, that doesn't change anything. Remember that when we are dealing with derivatives, we have x, this is some arbitrary number, raised to the power of n minus 1, and then we have an n in front. Now, that is always going to stay the same. And that is how we are going to look at this problem.
So to start off, we're going to have our exponent go all the way to the front here and become our constant. So it's going to turn into 2x to the negative third power plus 1. And of course, when we have this section here, we have to find the derivative of that. So here we have x to the negative third plus 1, and then it's going to be derived.
Right, and this is by the chain rule. That's why we do this outer layer, like an onion, and then the inner layer right here, and we have to derive the inner layer now, which we're going to do right here.
So because we have to find the derivative, negative 3 comes to the front, and then negative 3 minus 1 equals negative 4, which you get negative 3x to the negative fourth power, and this, the rest of the equation does stay the same. Now you want to multiply the 2. So you get negative 3x to the negative 7th, because remember, every time that we're multiplying 2 with exponents, they're added together.
That's right. Whenever we have exponents, when we multiply exponents and they have the same sign in the exponent, we add them. So whenever we multiply exponents, we add them. Whenever we divide with exponents, we subtract them. So that's what we're doing. We're just adding in here. And then, so this is factoring in here, and this is factoring in here. And so that's where this 3x to the negative fourth comes from, because it's being multiplied by this 1. And then we have a 2 out here.
And now we multiply the 2 into the whole equation, which you get negative 6x to the negative third minus 6x to the negative fourth.
Now we're going to move on to the second derivation. We've done the derivation 1. So
wait, hold on. That shouldn't be a 3.
Okay, so my friend made a mistake. She wrote negative 3 right here, where it should be a negative 7. And she actually caught that, which is pretty good. Remember, when we multiply our exponents together like this, we need to add them. So adding this negative 4 with the negative 3 is going to give us this negative 7, which is why we have the negative 7 here. And so again, we've done our first derivation. This is our first derivation done in green. We're looking at the green part now. We've gone through all of our steps, and now we need to find the second derivation. Second derivation is basically going to be the first derivation. We have this equation. It doesn't look too far off to how this is laid out. And we're just going to take the second derivative of it right here. So starting this off, we're just rewriting this in red. And now we can actually start deriving it.
And you have to make sure when you're finding the second derivative, so you don't get confused why you went from here to here again, you need to make sure to put 2 derivative marks to show that you're deriving it a second time.
Right, because these 2 represent the second derivative, and this 1 represents the first derivative. Now, there is a slight error, which we're going to fix right here, and that's because we had the negative 3 right here, but it's a negative 7, so this is right so far. Now, looking at this, we're going to take the derivative of this. It's super simple. Taking the second derivative is just looking at this part and then deriving it again. So, looking at this, this part's right. We have this part. If we derive this, we're going to bring down our negative 4, so we have negative 6 times negative 4, which will give us 24. And then we have to do our number up here, minus 1, so our exponent is going to be a negative 5. Now we have to do the same thing right here. We're going to take our negative 7, bring it out in front. We have negative 6 times a negative 7. Negative 6 times a 7 will give us a positive, because a negative times a negative is a positive, and 6 times 7 is giving us 42. So we are going to have a 42 out here, and then we have to take our number and then subtract it by 1, and so our exponent is a negative 8. So that means our answer is going to be 42, x minus 8, 24, x minus 5. So we fixed our problem. Now we need to factor some things out. So we're going to factor the exponents out, and we're going to factor the constants out. So looking at our constants, well, what is the highest thing that we can factor out? We know both of these are divisible by 6. How do we know that? Well, we had a 6 right here. That's the common. That's the largest thing. In fact, when we took this first derivative, friend, she's new at this whole thing, but what you could have done is factored out the -6. And since it's a constant, we won't have to deal with it. It'll be just sitting out front the entire time. And it would give us the same out here. We can see if we factored 6 out here, we would have just had a 6 right here. So factoring this out, just the 6 right now, we're just looking at the 6, we're going to have 7x minus 8, and then we're going to have plus 6 divided by 24 is 4, so we'll have 4x minus 5. Now, we need to factor out the x to the negative. And when we factor the negatives, we're going to be looking for the largest number in our exponent. When we factored out positive numbers, we looked at whatever was the smallest, like this x squared, it was the smallest here. And that's because the x squared is smaller than the x5. Now, with negative numbers, we know that negative numbers, they go like this. So we have -5, -4, -3, -2, -1, then we have 0, 1, 2, 3, 4, 5. So we would get the largest negative number, which is really the smaller of the two numbers. Factoring this out, we're going to take our x to the -5 out, and then we're going to have this. If we wanted to test this, we could just factor this back in, and we would see that this would give us the same answer as here, and then this would give us the same answer as here. So that's how you would go about checking your work, which is pretty important when you're dealing with semi-big equations like this. And that is how you would find the second derivative for this problem.